Okay, so um, I want to go over a couple of questions that you had sent my wife yesterday. Um, the first one has, and by the way, let me just give you a quick test taking strategy. Any question that says what's the following, if you had to guess, you have no idea how to do it, which of the following questions slightly more tend to be on the D side rather than the B side? Because the test makers, they want to have the people look through all the answers. So which of the following questions, if you had to guess, blindly guess, slightly better chance of getting it right if you click on C or D rather than A or B. Okay? And if you want to save some time, start with answer choices C and D. All right, so going into this question, which of the following pairs of numbers represents a perfect square? So the first number is a perfect square. Which means it's something. And the second number is going to be its square root. So this number is going to be this number. Okay, so this is going to be the perfect square, and this is going to be the square root of the perfect square. So for example, if this was 4, the square root of that is 2. If this was 9, this would be 3. So instead of working backwards, it'll be easier to work forward. So if you take 2 squared, it's 3 squared is 4, 16, 5, 25. Now, if you look at your answer choices, I still don't see it. I don't see a 6 and a 4. Nope, that's not 4. That's the square root of 8. That's not going to work. So I know automatically A is wrong. Okay, and B, 25 should be 5. This one's a little tricky. 5 is different than the square root of 5. The square root of 5 is 2 point something. So the square root of 5 is 5, not the square root of 5. Okay, so that one's a little tricky. That's there. This question right here is there to keep people off. Okay, so 25, the square root is 5. That's not the right answer. And we keep going. 25 times 25 is going to be way higher than 25. So the answer must be this last one. So let's take a look just to make sure. 16 times, oops, 16 times 16. 6 times 6 is 26. 6 times 1 is 6, 96. 1 times 16, and we have 256. And the answer was 256. Okay? All right. Now that's it for this question. Let's look at the next question. So the next question here, this is a what looks like a tough question. Okay? But anytime you have an x squared plus or minus, and then you have an x plus or minus, and you see fractions, that means you're going to say, hey, these are going to cancel. So chances are you're going to find a factor of x plus 1 on top. And you're going to find a factor of x plus 2 on the top. Now look over here. Difference of squares. Now if you have a perfect square here, and it's a perfect square here, all you have to do is take the square root of that, put it here, take the square root of that, put it here. One's going to be a plus, one's going to be a minus. So this question right here, x squared 1, I square root this, x. I square root the 1, 1. I do the same thing twice. Okay? One's going to be a plus, one's going to be a minus. This is called the difference of squares. So difference of squares, you don't have to go through the work of factoring it. You square root the first term, the last term. One's going to be a plus, one's going to be a minus. Okay, let's try that again. Let's do a hard one. Let's do, that. Square root the first term. Square root of the last term, copy it. 1's going to be a plus, 1's going to be a minus. Okay, so that's how you find the factors, the difference in squares. I'm going to erase this. That's not part of the question. So our question has 2x plus 5x plus 2 all over x plus 1. And we have x squared minus 1 over x plus 2. Now, I just showed you that the factor of this is going to be x plus 1 and x minus 1. Now, when you multiply fractions together, the tops multiply, bottoms multiply, which means I could actually switch places. I could bring this here. Okay? Whatever's on top is out with whatever's on the bottom. So if I have the x plus 1, that whole thing is not what that whole thing. Okay? So let's do this now. I'm venturing to guess that this is going to be a factor, this ugly thing right here. Okay? So how do I find this factor? Now, what do I have to do with x? So I have 2x squared plus 5x plus 2. And I know that it's going to be factorable, okay? Because they like to ask questions that are factorable. So if I know that x plus 2 is going to be one of the factors, okay? I'm just guessing that this is going to be one of the factors, so I can test it out. X times 1 will be 2x squared, 2x, okay? And 2 times 1 is going to be 2. 2 times 1 is going to be 2. Okay? One more time. X times 1 is 2x squared. And 2 times 1 gives me 2. So I'm guessing that this is going to be my factors. I just have to make sure that the outer and inner terms are going to be 5x. So 2x times 2 is 4x. And x times 1 is x. Yes, it's 5x. So just do a check to make sure that the outer and inner terms coincide with this. If you don't have time, you're running out of time, just know that this is going to be one of the factors. Anytime you see a polynomial like this or another polynomial, it's going to be factorable like this. Okay? So let's clean this up. I'm going to rewrite this, redo this question. So we have 2x squared plus 5x plus 2 over x plus 1 times x squared minus 1 over x plus 2. So anytime you have a fraction times a fraction with polynomials like this, know that anything with a square in it should be able to be factored. So here, I'm going to have a factor of x plus 2. And here, I'm going to have x plus 1, x minus 1, x plus 1, x plus 2. Right off the bat, let's see a difference in squares. I can easily do that. This is a hard one, but I'm going to use this as one of the factors. So I put it in here. X times what? X times 2x. 2 times what gives me 2. 2 times 1 gives me 2. All the signs are positive, so I'm going to keep both of these positive. Now this denominator is like this. This denominator is like this. Now all I have to do is multiply 2x plus 1 times x minus 1. I don't know how to multiply this. There are different ways you can multiply it. You can use FOIL. First times first, outer times outer, inner times inner, last times last. That's called the FOIL method. You can use the this times this, this times this, this times this, this times this. Or you can also use this method. You have the 2x plus 1 and the x minus 1, multiply these two, multiply these two, multiply these two, multiply these two, and then combine it all. Combine like terms, and then you have your answer. Okay? So that's how you do this problem. One more time. Factor that. I know how to factor this. That's going to be x plus 1, x minus 1. I don't know how to factor this. This is a tough one. Use this as one of the factors. X times what gives you this? 2 times what gives you this? Figure that out. Cancel out everything. Cancel out. Multiply whatever's left. Okay? All right. Now, if you have any questions on how I do the spaghetti, I call this the spaghetti strand method, or the box method to multiply it out, or if you need to see anything in detail, let me know. Otherwise, this question is done.